Hi, my name's Rohin, and today I want to talk about a plausible solution to space travel in the modern age. Imagine if you could go to space for the price of just 3 to 4 times that of a first class ticket in a premium airline today. So, this is my topic, Skyhooks, and I hope you enjoy it. So, I want to start by talking about what are the difficulties in space travel today. Well, it is hard, and to be honest, space travel is slow, and you can transport a lot, and on top of that, there's the risk of dying. Rockets are essentially canisters of fuel with a tip of payload at the end. Moreover, you have to send a rocket blazingly fast at Mach 21 just to escape the Earth's gravitational pull. All these factors pulled together make it highly improbable to send a manned mission to further parts of the universe, let alone the solar system. But there is a way we could tackle this situation. And I want to begin by asking the question, consider you were living a few thousand years ago, maybe not that long ago, and you had to get around a lake, maybe say 8 to 10 kilometers in diameter. How would you go about it? If this task was something you had to do repetitively, instead of walking around the lake the entire time, you would or could build a boat. And if you're going to use a boat very often, you would maybe build a dock or a yard. This is what we call infrastructure, the dock or the yard. And it has played a monumental role in accelerating the human race today. There may be roads for cars, railways, shipyards, anything. Infrastructure today has made transit and getting to places much more easier. It reduces costs, especially recurring costs, and makes travel cheaper every time you use it. The same analogy can be applied to space infrastructure, or infrastructure in space, if you may. It can make it easier to get out there and can do so much more cheaper. But how could we envision space infrastructure or a dock in space? Well, there is this one simple and promising concept that needs no new magic materials, no new science, nothing too huge of an investment, and this has been tested before. It's a simple cable and a weight attached together, and this is called a tether. A tether can be hundreds to thousands of kilometers long and would lie in low Earth orbit and would extend to outer Earth orbit. Spacecrafts, specially designed to use this tether, could climb it up like a ladder and could get launched at greater speeds at a greater height. This concept is called the Skyhook. Now, to understand why this works, let's imagine one of those round spinning chairs which you can sit on, or maybe a flat ceiling fan. Something circular and that spins. Mark 2 points on that, one close to the center, one close to the circumference. Now if you spin that disc, you'll find that the point towards the circumference covers a larger distance in a shorter time. This is the same effect that's seen in a skyhook. Also, if we were to rotate and make the skyhook spin on itself, it would be even greater. You can imagine this as a spinning top going around in orbit around the Earth, and the top having an arm stretching out and spinning along with it. A rotating tether would slow down its tip at the bottom relative to the Earth and would speed up at the top. This would give us a boost, more or less for free, and that would be equal to 2 times the tether's rotational velocity. Furthermore, fibers that could exist the strain already exist. theoretically. Some materials like Xylon prove promising. And to, shield our cable from asteroids and satellite debris, we could knit it like a piece of twine, make redundant fibers so as to reduce cuts and grazes and maybe give us time for repairs. This Skyhook would pass the same place over it many times a day, and that property would enable us to use small reusable shuttles to catch it. Of course, there are challenges to this. Not everything's good and easy. We can't lower the tether too low, otherwise it would burn due to atmospheric friction. And the lower part of it would be traveling at 12,000 kilometers an hour. Scientists estimate that the lower portion of the Skyhook would be traveling 80 to 150 kilometers above sea level. For this reason, we would have to build spacecrafts that could catch up to that speed. But mind you, this is much easier and cost effective than building rockets traveling at 40,000 kilometers an hour. Catching it is another challenge because there's only a 60 to 90 second window where you can catch the tether, and you'll have to wait for the next show by. We can solve this by having a fishing line of sorts, if you may. A 1 kilometer long extension with maybe a navigational drone to help the spacecraft connect to the tether. Okay, but what about momentum? Momentum is a property of the tether which is very troubling. Now, as we know, the tether is orbiting the Earth and spinning at the same time. Each time a ship would leave the tether's end, it would slow down the momentum, or it would make the tether lose, momentum or energy. This is fundamental because to gain energy from a body, as the spaceship would do, you have to take away energy from the body itself. And in doing so, the tether could slow down so much that it could crash into the atmosphere. But this is where we can cheat the universe. The tether itself is, in all sense, a rechargeable battery of orbital energy. So, if leaving spacecraft take energy away from the tether, why not use arriving spaceships to refuel it, or in the sense, add momentum, add energy to the tether? Incoming spacecrafts, which might be carrying people, samples, materials back to Earth, could slow down and transfer their momentum to the tether. This new gain momentum would be used by further ensuing ships that want to leave Earth. In doing so, the tether itself does not lose much of its momentum and can keep going on. And of course, since nothing is perfect in the universe, if there are any changes in the tether's orientation and momentum, we can use small thrusters, chemical or electrical, to correct it now and then. The uses and application of these tethers is monumental. Imagine two between Mars and Earth. This can make the transit between the two planets fast, straightforward, and much more lowering cost compared to that rockets. So you can imagine that the low Earth orbit tether would pick up a spacecraft and fling it to Mars, and the Mars tether would just softly bring you back in, just like a normal plane landing. The counter trip, or from Mars back to the Earth, would be even more easier. Because of Mars' thin orbit, a spacecraft will only have to reach a velocity of 1,000 kilometers an hour. Not much more than current day airplanes. This could drastically reduce the time required to travel between the new planets. Pardon me. This could drastically reduce the time required to travel between the two planets from 9 months to just 3. And you can reduce the scale of the rockets required for the same by about 84 to 96%. Furthermore, we could also invest in passenger comfort. You could get a first class ticket to Mars. Imagine that. Champagne, on your space flight. But why stop in Mars? From Mars, we could send rockets and, excavators to asteroids. The first excavation would require rockets to slow it down. Further, spacecraft would meet a tether waiting there to help them slow down. We could essentially bring minerals and metals back to Mars within weeks of excavation. These are the building blocks for a solar system-wide colony if we were ever to build one. But of course, we don't have to stop there at all. No other moons in the solar system orbit as closer to their home planet as the moons of Mars. Phobos itself is so massive that we don't have to ever worry about slowing it down. We can create something called a super tether, which would be two hooks attached to the same counterweight, the moon itself. And this could be under 6,000 kilometers long. These could enable travel in just one swing to Jupiter and Saturn. Furthermore, you can also bring the inner solar system closer, and with Mercury and Venus being a swing away as well. These planets are bursting with solar and mineral resources. In short, nothing is stopping us, the human race, from creating a zero-propellant transit system based on the Martian moons. Tethers can make space travel affordable and the solar system widely accessible. So you might ask, what's stopping us then? In all practicality, nothing. In all non-practicality, everything. We on Earth have a lot of priorities, and not to call shame on them and call them nothing, but if we are to think about our future, we gotta act now. Yes, of course, there are certain things that move certain people more on Earth than looking up at the stars, and I wholeheartedly believe that. But if you want to think about the future generations and where we could live in a worlds far, far away, this could be eons, of course, but I feel it's important to start now. So, to end, I'd like to say that our limits, our boundaries of space exploration is just in our minds. It's in our hands, because we effectively have the technology to do so. So, I conclude by saying, let's give a shout for space exploration, and I hope to see you on Mars. Bye.